basically what I wanted to do was to just give a quick overview of 3 of the projects that I've been working on with students and colleagues at Cornell. And it's in the area of natural language processing. So my plan was to give a couple of slides for background just to make sure everyone's on the same page in terms of natural language processing. And then I'll cover the 3 topics that were in the little blurb. We'll look at work on understanding opinions, and then work on deceptive opinion spam, and then public participation in electronic rulemaking. And hopefully it'll all fit together in the end. So along with a couple of others at Cornell and in the computer science department, I work in an area called natural language processing. And it has basically kind of dual or sometimes dueling goals. So on one hand, what we'd really like to do as a field is to develop systems that can process and produce language as well as people can. But don't hold your breath for that to happen. It's really hard. And so in the meantime, we work on more of an engineering type of goal where we're really just trying to make incrementally, in both small and large jumps, systems that will perform better and better at understanding or generating language. Most of the systems or the algorithms that I'll talk about can be described in terms of this input-output structure. So I'll walk you through that, and most everything that I'll talk about I'll describe in terms of what goes in and what comes out. So half of the field of natural language processing actually works in something called natural language understanding. And there, the goal is to take some natural language input, and for me, it's always text. So, but for some others, this might be speech, which is an added complication. So we'll take some natural language input, and then we want to understand something that's in that, the text or the documents, and then maybe produce something as output. But the basic idea is just to understand something that's in the text. The second half is called natural language generation. There's much less done in this area. The generation piece, the idea is that the system has some concepts that need to be expressed. And so natural language generation systems will take those concepts and produce hopefully fluent sentences that describe the concepts. Okay, and everything that I'll talk about will really be focusing on this first half, that natural language understanding. Okay, and now is the fact part of the fact fiction and federal regulations. A lot of the work that I've done, both as a graduate student and at Cornell, is in something called information extraction. And it's, in general, most of the research in the field has focused on processing texts that are factual in nature, facts, events, but not fiction, no stories. And that's the kind of area that these systems operate in. So an information extraction system would take as input some text collection, and we'll look one document at a time at trying to summarize succinctly the key points in the story. So these systems are usually designed for a particular domain. It's a domain-specific type of extraction of information. So the input might be a document, and then the output, say about some events, and then the output would be a short template-based structured output that will indicate who was mentioned, what was talked about, where it happened, when it happened, how it happened. Probably not why, because that's too hard. So I'll give an example. So this is the input and output for an information extraction system that operated in the area of natural disasters. And we built this in my group at Cornell and with a company from Ithaca, Cogentex. So here the domain is natural disasters. And so the idea is that the system would take stories that that are about some natural disaster, and then pull out all of the key pieces of information. So from this document, thousands of people are feared dead following a powerful earthquake that hit Afghanistan today. The quake registered 6.9, and it was centered in a remote part of the country, and entire villages were buried by the quake. The output is basically who, what, where, when, how, but it's tied with slots that are really geared more for the specific domain. So here there's an earthquake. The location is Afghanistan. We have a date, the magnitude, an epicenter, the damage in terms of people that are either injured or killed, and then physical objects that are either damaged or destroyed. So that's just one example, but there's been a lot of work on text that is event-based. And that's basically what Watson was doing, right? The question answering system from IBM, it's trying to answer questions, but not necessarily to give opinions on anything. So now on to the opinions. These two are the fiction part of the program. Since everyone was working on facts and events, about 10 years ago, colleagues of mine and I were one of the first to look at subjective language. And so that's going to be basically the topic for the next two bullets. And I'll start by just to give a background. So I call this opinion analysis, and I'm using opinion kind of as a shorthand, because basically what we're working on is trying to extract information from subjective language. And by subjective, we mean any kind of text that expresses a speculation, belief, emotions, evaluations, goals, opinions, or judgments. In the social media, you'll often hear talk of systems that can perform sentiment analysis. And actually, sentiment is one subtype of subjective language. And it's sentiment-bearing text is text that has some polarity associated with it. So subjective, an emotion that is either negative or positive you would say that is a sentiment-bearing sort of subjective language. I'm going to work on all of this, and I'll just call it opinions, just for shorthand. In this area, actually, there are a few ways that you might tackle this. I mean, what kinds of ways would you like to understand subjective language? Most of the work in the field looks at what's called document-level sentiment analysis. And this is actually work that was started by Lillian Lee, who is a colleague of mine in computer science and one of her graduate students who's now at Yahoo. But the goal for this type of sentiment analysis or analysis of subjective text is the following. You give the system a document. They worked on movie reviews. And then the goal for the systems that they build is to determine the overall sentiment in the document. Is it positive or is it negative? Okay, so that's all they're trying to do is, given some document where you know the topic, hopefully, is the overall sentiment positive or negative? So this kind of system is really quite good in the cases where you know either you don't care about the topic or there's only one main topic in the text, and you don't care about who is saying what. But from my point of view, there were lots of applications where knowing who is giving the opinion and knowing more specifically what the opinion is about, and being able to deal with texts that might talk about multiple opinions on different topics, not a single topic and a single overall sentiment. That handling text like that was something I was interested in working on. I thought there would be lots of applications for it. And in particular, we were inspired part of the way along this by this is from the New York Times in October 2005. It's called The Blame Game, and it's basically a summary of who's saying what in terms of, well, this is right after Katrina and all of the disasters that ensued following that. Who was at fault? So this is basically a summary of the key players, and everything is negative. So the edges in the graph show who is the opinion holder. So this is Bill Clinton, and he is blaming Michael Brown of FEMA and George Bush, who's president. So to create some graph like this, you would need to do more than characterize the document in terms of positive or negative. And this is the kind of thing that we were hoping to be able to develop methods to create automatically. So for example, in a quick view, you can see very quickly that everyone's blaming Michael FEMA. He's blaming the churches. Bush, like all good presidents, is blaming himself. And Rush Limbaugh has his own ideas about what's going on as well. So these were opinions taken from multiple documents. And each edge shows the sentence where one person was saying something negative in terms of blaming someone else. So my research and the research of my group is aimed at methods that can recreate that sort of graph. And for that, you need something called fine-grained opinion analysis. So this is analyzing subjective language, not at the document level, but at the level of individual phrases. And so I'll give you an example. This is based on the previous slide. It's Michael Brown added, it is the responsibility of faith-based organizations and churches to help those people. Okay, so from this sentence, a fine-grained opinion analysis system would try to find every expression of, every subjective expression in the sentence, and for each one, determine who is the opinion holder, so who is expressing the opinion. In this case, it's Brown. Is the sentiment positive, negative, neutral? What is the intensity? Is this weakly expressed, medium, high, extreme? And what is the topic or target of the sentiment? So this is saying that Brown is negative towards faith-based organizations and churches. So for every expression that's subjective, we would extract some sort of opinion frame like this. And the idea is that if we can do this within the sentence level, then we can always aggregate it up to either summarize the opinions in a paragraph level or in the document level or even across a whole corpus. So does this make sense? Okay, so this is the only technical slide, but it'll explain our general approach, and that will cover everything from now till the end. We use statistical and machine learning methods, and that might sound crazy because this is language, but I'll tell you basically how it works with one example. So let's say that what we want to do is to build some system that can find all of the people who are expressing opinion. So we want to know who are all of these opinion holders in a document. And the last example, that would be, we want to identify that Michael Brown is an opinion holder, someone expressing an opinion. The learning methods that so basically what we do is teach up a system how to do this. And like all good teachers, we give the system lots of examples of exactly the concept that we want the system to be able to reproduce. So we would give the system lots of examples, and these are called training examples, of sentences with the opinion holders highlighted. So we'll give the sentence and we'll say, okay, here Brown is the opinion holder. In this sentence, George Bush is the opinion holder. So we're essentially giving the, a context and then annotating by hand exactly the information that we would like the system to be able to learn how to produce. So that's training. The catch in all of this is how we represent these examples for the system. And these are represented in what people call features. And you can think of it as any information, anything that might be a clue for the system as to where the opinion holders reside in the sentence. That will be encoded as part of the training. So for opinion holders, they're usually noun phrases. So this means that if we want to do well, we'll have to also, as part of the input, show where every noun phrase is, because a noun phrase might be a good guess as to where an opinion holder is. So the catch in all of this is designing a good set of usually linguistically based features, each of which is a potential clue for the system to point out where you might find, say, the opinion holders. So those are given, so we'll give hundreds of these, at least, to a system. And it can do anything at once with these, but there are dozens and dozens of approaches that will process these examples and try to basically generalize from the examples that it was given, after which it can produce another program that we call a classifier. And that classifier will then be able to take new sentences, sentences that the system was not trained on. We represent them in the same, using the same set of linguistic features as we did during training. And then based on the examples that it was given for training, it can then make a hopefully good guess at where the spans in the sentence are that have that indicate the opinion holders. So this is the basic approach that's used across natural language processing and other areas, with big variations in terms of the kinds of classifiers, the kinds of learning algorithms, the way to represent the input data. But basically, we give lots of examples that are labeled with the correct output, and then produce a system that can take sentences it's never seen and try to perform the same task. Okay, so we do that we do that for every piece of this. That works. Opinionframe. So we have a classifier that can find the subjective expressions, that can find the opinion holders, the targets, the intensity, the sentiment, with varying degrees of accuracy. But that kind of system was exactly what was taken by an entrepreneur here in New York City, actually on 41st Street, to be the basis of a company that does opinion analysis. So I am one of the co-founders of Appinions, and they took exactly that technology and have done really good engineering on it over the past 2 years. But at this point, the system will, a system like this can take documents that are being produced online, basically all the time, and scan them, trying to find opinions. And so every time it finds an opinion, it will store it. And store it in a database that says, okay, Michael Fima said something negative about churches on this date, or something positive about churches, sorry, on this date. And it was a weak positive statement. And here's the portion of the text where we inferred that information. So you can always drill down to the actual source and see if the system is right. These get stored in a database, and then any application that Appinions produces is basically just doing something with that opinion store, with all of those opinions. So what are kinds of things that you can do? That we can create kind of gadgets on the fly. So this was done around the Oscar time. And what you see here is really just exactly the opinion. So opinions on Black Swan over a 3-day period, extracted from places on the web. The green indicates the percentage of positive opinions, neutral and negative. And so it's kind of a nice picture that lets you see basically what the thoughts are on the contenders for best movie. For any of these, because we keep track of where the opinions came from, you can actually examine all of those 99 opinions if you wanted to and see if you believe them or not. The Economist actually uses this to produce what they call an opinion cloud. And so this was one that was produced based on the same set of data as the last slide. This was a couple of days before the Oscars. It's indicating that Natalie Portman and Colin Firth are getting a lot of attention, and Social Network as the movie also is getting a lot of attention. And just after the Oscars, it looked a little bit different. So there's lots of opinions on the Oscar parties, still opinions on Social Network. And then something that initially looked weird to me, but James Franco, not having watched the Oscars, I didn't know why he was now being talked about a lot. And did any of you see the Oscars? He was a co-host, and people did not like his co-hosting. He co-hosted with Anne Hathaway, and so looking closer at what's happening under James Franco, you can see the opinions here. This was from Wendy Ledger. This is a blog, I believe. I think it will be a challenge for James Franco now to win an Oscar. This is a full sentence. Kyle Daly says, "Why were you chosen to host the Oscars? I asked myself," in an open letter to James Franco. So if you look through these, you'll be able to see why these clouds are the way they are. And underneath it is it's just these extraction of these triples. Who's saying what about whom? Yeah.
Just silly, but is this real time that you guys do?
It's basically real time. So we just they ingest opinions all day and all night, and just keep them in the database. Yeah.
But in the margins, aren't there problems because, I asked myself why you were chosen, so that's maybe obviously negative, but what about comments that are ambiguous? How do you classify those?
Yeah, so this is really hard, and so one of the things that I was really a fanatic about is making sure that people could see where the information was getting pulled from, because the system does make mistakes. We find opinion holders correctly about 85% of the time. The hard part is actually getting the polarity right, and so you'll see that these white are things that either are ambiguous or that weren't quite strong enough to be either positive or negative. One of the things that we saw in developing the system is that what people really hate is if they see something that they think is positive and it's labeled negative, or if they see something negative and it's labeled positive. But if it's mislabeled as a neutral, that's a little bit better. And so we train the system to prefer those kinds of errors over making the positive-negative distinction. So underneath this is a lot of, we're doing, do you ever have to do sentence diagrams as kids? So we have these parsers that build the sentence diagrams. There's part of speech tagging. This
is all automated.
All automated. So there are like 30 or so linguistic components that are underneath it trying to make these decisions. And those components are what provide these features for the learning algorithm to give it clues as to where to make which decisions. Okay, so I'll skip ahead on to another area that you can do since this is a social media topic, you can use the opinions also to create a social network that's based on who's saying what about whom or what, and then look to see what people are driving the opinion on a particular topic. And so that's, again, another application that's just built on top. Okay, so now the second part of the fiction piece is the work that we were talking about just before we started. So this is recent work that I did in conjunction with Jeff Hancock, who's at Cornell in the Communication and Information Science Department, and our grad students, of course. So I'll give a quick overview of that, and then, because I know some of you don't know about that, but I'll add at the end some of the new directions and new results that we have in this particular area. So again, still subjective language that we're looking at, but this time we were interested in doing something with reviews. In particular, Mile, who's the grad student who's the main force behind this, is addicted to reading reviews of everything on the web. Uses them to rate, review, and research products online. And there's clearly a lot of potential for spam, what's been called in the literature opinion spam. We think about it in terms of two different types of opinion spam. One is called disruptive opinion spam, and this is opinion spam that's clearly spam. So when you read it, you can quickly determine that this is not appropriate in some sense. So an example of this is a review on the right that's supposed to be a review of the iPad 2, I believe. Yeah, the Apple iPad 2. But as soon as you read it, you see it's not. We Ship Tech is a great, reliable company. So it's basically about the shipper. It's not about the iPad. So these kinds of things, while annoying, are not so dangerous for the reviewer, I mean for the reader, because you can discard them and not pay attention to them. We were interested in a more insidious kind of opinion spam, and that we call deceptive opinion spam. The idea here is that deceptive opinion spam is some opinion, some review that's fictitious and that was written expressly to convince you of something that might or might not be true. So it's a fictitious opinion, deliberately written to sound real in order to deceive the reader. One case of this was from 2009. A Belkin employee was trying to get the ratings of one of their poorly rated USB hubs higher, and hired people on the web using Amazon Mechanical Turk, which I'll talk about in a minute, to write positive reviews, but he was caught and then fired from Belkin. So this is one of those reviews. It sounds real, supplies good range, and does provide true wireless USB. Software worked right out of the box. I've been recommending this nifty little device to all my friends, very useful device. So these are the kinds of reviews that we're interested in finding, ones that are fake, deliberately written to sound authentic. Why would we want to do that? Well, these are hard, it turns out, for people to identify, and they might really influence your decisions. Maybe hotels or USB hubs are not so important to get right, but if you're using this to choose your doctor or something, then that's a bigger issue. So just to give you an idea of the difficulty, we'll look at two of these reviews. One of them is deceptive, one of them is real. And we'll see if we can tell which is which. So first one, these are from on the same hotel. This is a James Chicago hotel. I've stayed at many hotels traveling for both business and pleasure, and I can honestly say that the James is tops. The service at the hotel is first class. The rooms are modern and very comfortable. The location is perfect within walking distance to all of the great sites and restaurants. Highly recommend to both business travelers and couples. Okay, the second one, my husband and I stayed at the James Chicago Hotel for our anniversary. This place is fantastic. We knew as soon as we arrived, we made the right choice. The rooms are beautiful and the staff very attentive and wonderful. The area of the hotel is great. Since I love to shop, I couldn't ask for more. We will definitely be back to Chicago, and we will for sure be back to the James Chicago. Any ideas? Which do you think is the deceptive one? The first is deceptive.
I would have voted for the first, but I'm troubled by, since I love to shop, I couldn't ask for more in the second.
And that's what you're thinking. So normally when we do this, and
it doesn't seem related to the hotel.
So it doesn't seem related. Okay, so the, sorry?
It's hard to tell.
It's hard to tell. So we've changed these examples a lot, and still if you ask a room full of people, it's mixed. This is the fake one. And in a minute, you'll see kind of why. First of all, from my colleague Jeff in communication, he's our deception wizard. People are generally poor at being able to detect deception. So the number he gives is about 50, just above chance. What we wanted to do was to see if automated methods could potentially do better. And so we're using our same basic machine learning technique from before. This time it's called text classification, but it's the same idea. We'll train the system by giving it lots of reviews that are labeled correctly as either being fake or being truthful. So we give it examples of both fake reviews, truthful reviews. The machine learning can do its magic, produce a classifier, and then, take in new reviews and make a guess as to whether it's fake or truthful. In this case, the clues that we give the system access to in terms of these features, for each review, we tell the system that, well, any of the words in the review, that might be a clue. Any consecutive pair of words, that might be a clue as to being truthful or deceptive. We also looked at linguistic features from the psychology literature that are associated with deception. So this has to do with the use of, say, personal pronouns. If you're a liar, if you're lying, for example, you tend to want to distance yourself from what you're saying, and so you tend to use fewer I's and my's, so fewer first-person pronouns. So there are a collection of these kinds of cues or clues that we make available to the system so that the learning algorithm can potentially use those in building the classifier. The catch here is we need training examples. And so how do we get those? First, how do we get deceptive reviews? I already said we can't really read, say, TripAdvisor reviews and have people tell the difference because we can't do it. So we picked 20 hotels from TripAdvisor, all in Chicago, and decided to focus just on positive reviews and finding deception in positive hotel reviews. So we need, again, 20 reviews for each of these 20 hotels. That is fake, a fake positive review. So we did what the Belkin people did, and that's go online to Amazon's Mechanical Turk, and we post a job saying that we'd like you to write a fake positive review, pretend that you are an employee at a hotel and your boss asked you to write a review that shows the hotel in a positive light. And if they do it, then they get $1. And so we got, there it is, we get $1. We did this for 20 times 20, so we ended up having 400 positive reviews that we know are deceptive. We checked them for plagiarism, so we know that they didn't just steal something from the web and reuse it, so a few people tried that. We get rid of ones that are just gibberish. So these were looked at to make sure that they seemed okay. 400 different people also gave the reviews. To get the truthful reviews, that's easier but not perfect, and this is exactly what you were asking about beforehand. We wanted to mine some existing site for truthful reviews, so we needed a way to make sure that we weren't pulling in deceptive reviews along with the truthful ones. To do this, we focused on the 20 most reviewed hotels. So these are hotels with lots of reviews. So oops, it's zipping ahead. From Chicago, the idea is that popular hotels, because they have so many reviews, it's not worth it that much to provide a fake review because it's already a positive. I mean, they've already got you've got so many reviews that one more review isn't going to make a difference. From those, we get rid of the non-5-star reviews, so we only want positive reviews. We get rid of reviews written by first-time reviewers because there had been some notion in the literature that first-time reviewers might be deceptive in the sense that if they're being paid to do this, they would get a one-time login ID and write one review and then never post again with that name so that they're not caught. So we get rid of the first-time reviews by first-time reviewers. All of these things just to try to make sure that we, as best as we can, are focusing on truthful reviews. So we have our data set now. We have 400 truthful, 400 known deceptive reviews, 20 of each for each of the 20 most popular, most reviewed hotels in Chicago. So now we have our training set. Just as a check, we got 3 of Jeff's undergraduates to guess whether or not these were truthful or fake. So they took a subset of the data, and one did reasonably well, 62%, and the others are basically close to chance. So it really is hard for people to identify these. The system that we trained ended up doing incredibly well, much better than we thought, and about 90% accuracy. So that's very cool. The thing that's more cool, though, is just to look to see. This is from the New York Times. Thank you, the New York Times. Is to look to see which of these features, which of the clues, are the ones that the learned classifier is focusing on the most in making its decisions. So the features will get weighted by the learning algorithm, with the top weighted features are the ones that are most important for making the decision. And here we found some interesting results. Some of the strong deceptive indicators, so strong indicators of deception. These are phrases that focus on either who you were with or why you were in the city. So my husband and I stayed in the Hotel James, Chicago. The truthful reviews, on the other hand, tended to focus more on fact-based descriptions of spatial things within the hotel and in the general area of the hotel. This is consistent with the literature in deception that shows that if someone is lying, they're not very good at providing spatial information, and they tend to not provide spatial information, presumably because they haven't been there. And that's what's happening with our deceptive reviewers. They're not giving spatial information. Instead, they say who they were with and why they were on the trip. A result that's opposite of what was expected. We see that fake reviewers use first-person pronouns, I, me, my, myself, more often. This is not what you would expect because of this principle of the psychological distancing. Jeff and we think that it's because, in this case, we're explicitly telling the reviewer that it has to sound authentic. And because we're pressing them to do this, they insert themselves into the story more than we would expect. Some slight deceptive indicators, high adverb use and high verb use. This turns out to be consistent with the types of the part of speech that are used in fiction and imaginative writing, as opposed to nonfiction or informative writing, where the focus is more on nouns and prepositions. And the exclamation point, so positive emotion is more for deception. The truthful reviews also rely on punctuation a lot, but more on commas and semicolons and not emotion-laden punctuation. So where are we going with this? Since this was an article from this summer, and we just submitted a new article on Monday, actually, so it's under submission. But what we did was to rely on the fact that we can now predict with 90% accuracy, approximately, truthful versus fake, at least among popular Chicago hotels. Okay, so that's where we are. But we thought that we can use this instead to answer questions that have been coming up a lot, which are how much deception really is out there on these sites of reviews. So what we did was we used a method from the medical informatics and trying to predict the prevalence of a disease, where you don't know exactly how prevalent a disease is, but you have certain tests that you can run on a subset of the population. So maybe you can run a blood test on a tenth of the population, and that will give you the prevalence rate among that group. But these methods will extrapolate from a single test or multiple tests on a population to predict prevalence across the whole more broad population. So for us, our classifier is like a medical test. And so we have our classifier that we can train and use it as a test, and then extrapolate from there to see how much is what prevalence there is online. Now, I'm only going to give you a couple of the results.
Isn't a medical test objective? You said a medical test.
Oh, so it's not objective, actually. So we end up keeping the same, keeping track of the same kinds of information that they do. So in the medical test, there's lots of false positives or false negatives, and they typically know, they have a guess at what those rates are for a particular test. And similarly, we can create those same sort of numbers for our classifier given the data sets that we have for training and testing. It's really an estimate. So in fact, in our submitted work, we don't make much of the actual raw numbers that are estimates, but instead just the trends that we see. And I'll show you just two of the graphs just to give you an idea of the kinds of things that we were looking at. So there's this claim that reviews written by new users, so first-time users, are more likely to be deceptive. So we can test this in the following way. We gather 10,000 positive reviews from over 100 Chicago hotels on TripAdvisor. We have our classifier that's been trained on a different set of reviews, but from the same general population. And we can then estimate what the prevalence of deception looks like among these 10,000 positive reviews from TripAdvisor versus the same hotels for Hotels.com. Now, the difference here is in Hotels.com, you have to book through the site. You have to pay through Hotels.com to book your room. And only people who have booked through Hotels.com for a particular hotel are allowed to post a review for that hotel. So it's a much more stringent test. With TripAdvisor, anyone can just create an account and then post a review. So what we would think is that we'd see less, in general, less deception at hotels.com than TripAdvisor. And then we can also look at single-time reviewers. Okay, let's see. I'll explain this just quickly. In red, well, let's do the blue first. Along the y-axis, this is the prevalence of deception among the 10,000. So this says it goes up to 10%, down to 0. Across the bottom, this is when we measure the prevalence based on the number of reviews that were written by the reviewer. So here we see we look at prevalence among reviewers who have only posted a single review. So this is the first-time reviewers. They posted one review. Very high, 8% look like they're deceptive according to our estimated, what the classifier is saying. If we look at this is actually makes up a third of the TripAdvisor reviews, our first-time reviewers. If we look at people who have written at least 2 reviews, it's the minimum number of reviews. A minimum of 2 reviews. Already, just dropping out the first-time reviewers, we can see a real big drop in deception. For 3, 4, 5, it keeps going down and then levels off. So this seems to indicate that there might be something to this claim that there's first-time reviewers are deceptive. Hotels.com, it doesn't really change. And that's potentially because there are fewer deceptive reviews. We've got one other. We can also look at the prevalence of deception across these review sites, the same grouping of hotels, but over time. And again, it's hotels.com in red, TripAdvisor in blue. These are all the reviews that we have from both for January 2009 and before. And then we look at ones that were posted only from March of 2009, May of 2009, and forward. So you can see as we go over time, both are increasing in terms of the amount of deception, but hotels.com is increasing at a much slower rate than for TripAdvisor. So this is, I think it's kind of an interesting way to get a sense maybe of what's happening on these sites. And it's good news actually for TripAdvisor because it seems that one thing they could do is just don't post a review until by someone who's a first-time reviewer. Wait until they review a few more hotels and then let their reviews out there.
Now, what's the reason you think first-time reviewers are more problematic?
I think it's because they know they're doing something deceptive, and they don't want the, say, TripAdvisor to know that they're deceptive. So they might post. They will change their account, change their TripAdvisor account names. They create new accounts when they're posting deceptive reviews. Okay, so this has gone far longer than I thought, so I will just tell you briefly about the other two, the one other piece of work that we're working on. But one interesting thing is that when we started this, TripAdvisor had this logo, Reviews You Can Trust, but about a month ago, they changed it, and now it's Reviews from Our Community, which I think is very interesting. So I don't know what's happening there.
What does TripAdvisor think of what you're doing?
So they contacted us right away, but after that, we haven't been able to get them to respond.
Is this they contacted you after the first study came? I mean, they don't know about the second study.
No,
prevalence,
nobody
this
knows.
This has not been published.
It's not published. Yeah, it's not published.
Is it the same team doing the second study, you and Jeff
and Mile, but not Yejin. She's at Stony Brook, so at this point.
And the second study is the prevalence, basically the prevalence issue.
Right, the prevalence issue. Yep, and the paper has some theory behind how to judge which sites or which reviewers or which sets of reviews might exhibit more deception or not in terms of something from economics, signal theory, the idea that if it costs more to be deceptive, then you'll be less deceptive. And you can just make guesses at how to measure that. So the last piece, it seems quite different from the others, which started with fact and then fiction and now electronic rulemaking. And here I'll just tell you the quick idea. In electronic rulemaking, there's often a site, when a regulation is being proposed, the agency that's proposing it often will run something called a notice and comment rulemaking. And here each of the agencies, let's see, I have this part here, they'll spend a long time drafting a proposed regulation. Say Department of Transportation says we need better safety belts for children under the age 10. So Congress says this, and then it goes out to, say, Department of Transportation to fill in all of the details. They may spend a couple of years trying to do that, produce maybe a 40-page regulation that then has to be exposed for public comment. So they post it in the Federal Register along with all of the supporting documents, and then there's some period where anybody at all can submit comments. After this comment period is over, the agency has a legal obligation, if they decide to go ahead with the regulation, in that they have to review and respond to any significant comment that was submitted during the comment period. So it turns out that even though this is it's the easiest and probably most important way for people on the street to actually have a say in what becomes law. These regulations are laws. It's an incredibly slow and very expensive process. So there's about 4,000 estimated regulations that undergo this process each year, and they take a number of years to get proposed. So the cycle is a 2 to 5 year cycle for each regulation. So we wanted to use some digital technology to help this process. Initially, we were looking at how to help the agency in doing the comment analysis step. But more recently, we were looking with the Department of Transportation at whether or not we could do something that would really change public participation. So Department of Transportation wanted to explore the use of social media in the comment process, but it's impossible to get a major change in the rulemaking process okayed in, I don't know, in anything shorter than a decade. So we're working with them in the following way. We have a site. It's called regulationroom.org. And for selected rules that they're hoping to get a lot of public participation on, we also we put up a site, and it has a couple of purposes. It will take these 40-page regulations and with the lawyers on the team, translate it into regular language, break it up into pieces so that it's much more accessible. So that's one piece. This is an older interface to Regulation Room that was used when there was a Department of Transportation regulation on the airline passenger rights bill. So the kinds of things that are issues that they wanted feedback on from the agency are tarmac delays, ticket oversales, pricing and advertising, baggage and other fees. The site basically lets people understand the issues in a hopefully easier way, post comments, and then respond to one another in the comments. For example, one of the issues is peanut allergies and planes, and the comments people can enter on the right-hand side. The goal is that by the end of the comment period, with the help of law student moderators, the site will end up producing maybe more participation, but at least more informed participation from the people who are collaborating. At the end of the comment period, the whole group collaborates to produce a summary of what's gone on over the comment period in Regulation Room, and that is submitted as an actual comment to the rulemaking. So there's some incentive for people to hash things out here. We do the work of aggregating and summarizing, and then the comment is submitted to the real site. So where's NLP, where's natural language processing involved here? A couple of places. This is the newer version of the site. And the newer version of the site, you can start seeing moderator interventions over here. So I took a couple of pieces here. This is for a new rule that's under comment right now on making airline kiosks and air travel sites accessible to people with disabilities. So one person, Nat Potter, said, "Are you sure that DOT and DOJ are the best people to propose these standards?" So this is a comment from someone commenting. The moderator decides to intervene because this turns out to not be very useful to the agency. What they're trying to do in this intervention is to make them think a bit more, maybe provide more information, and hence a better comment. So the moderator said, "Welcome back. Can you explain a little bit more about why you think DOT isn't right?" So there are all kinds of these moderator functions, and this is the part we're trying to look at automating on the natural language processing side. Not to do the moderation ourselves, not to have the system do the moderation, but instead to just prompt the law student moderators to watch out. So for example, we can watch for something called cognitive tunneling and fixation. So this is when one line of discussion is fixated on one specific aspect and they're rehashing it over and over, and they really should broaden their discussion. If we can determine this, then we can tell the moderator, "Hey, watch this line of discussion. Maybe you can help intervene and broaden the discussion." We can potentially find unconstructive comments, so this is more policing, and then point the moderator to check, make sure that this person isn't really disrupting the discussion. Off-topic comments, we want to let the person know that they're posting them either on the wrong site or on the wrong part of, or with respect to the wrong issue. To help moderators provide support in terms of improving comments, it would be good if we could find comments that have unsupported claims or statements, and then ping the moderator to say, maybe you could prompt to get more information. So these are the kinds of things that we're working on in the background to try to improve things. And I'll stop there. This is the very end. There. I'm sorry it actually went longer than we had thought.
I know it's late. I'm curious, do you ever run your truthfulness filter for the government comments and find?
Oh, no. So, but actually, if you go to, Mile put up a site, reviewsniper.com, I think. And there's also a .org site. Let me check to see which one I should. Review Skeptic. Reviewskeptic.com. What it does is it just lets you cut and paste text from somewhere, cut it from some review, paste it into our little box.
And you assess it?
And it will assess it based on the classifier that we've trained. But remember, it's trained on just positive reviews, just Chicago reviews, hotels, but you can try it on anything.
ReviewSkeptic.com.
ReviewSkeptic.
And that's up and going now?
Yep.
And that's built on the research work you guys have done?
Yep. Yep. So that's there.
Well, Suzanne, you should have fun with that.
Okay.
I'm going to say 8 to 10% deception seems pretty low. I mean, I feel good about that if that's what your research has revealed.
It's actually, so those are slightly older, those were produced before the paper, so it's actually even lower than that. And that's a good thing, because what we've read, it seems that some people are estimating 20%, and that seems really high, at least for the kinds of reviews that we were looking at.
I learned something once in the hotel business that if you have a good experience, you'll tell 2 or 3 people. If you have a bad experience, you'll tell everyone you know. So I wonder if there's more human nature to write once it's bad versus once it's good. You know?
I wonder. So we're doing this same study that we did before, but now with negative reviews. And so we'll see. We have all of the...
Doing the same thing with negative reviews that you did with positive.
We did with positive. So we have all of the deceptive reviews from Amazon Mechanical Turk, and we're running exactly the same sets of experiments, and then the same prevalence kinds of experiments to see the difference in positive and negative deceptive.
Are you hoping that'll be a paper down the line?
That one should be a paper by January, the negative reviews.
Are these going to when you submit these papers to the same journal as the first one, the hotel first fake review study?
The first, they go to computational linguistics. Right. The prevalence went to dub. It's a conference on World Wide Web stuff. Yeah.
And when is the second one, the prevalence one, when will that be public, or is that something that's kind of public now?
It's, they'll let us know about whether papers are accepted in February. So it's a long time.
Oh, but the other one is going to be January, you said?
For submission.
Oh.
And so that'll probably be April or March. That's a shorter review period for that.
Do you think the classifying process could be streamlined? You did it to a specific Chicago hotels. Is there a way to extrapolate that to improve classifying other candidates?
So that's a great, that's actually a research issue for us. We can do it, we believe, for other hotels pretty easily by taking out the identifiers and replacing them with, so instead of the James Hotel, we would call it Hotel X, and instead of Chicago, we put city. So we think that that will work as long as we stay in the same general hotels. Now, if we move to some other type of review, we don't know.